Okay. So good evening, everyone. So let's see how to do the 2019 series question. Okay. Okay. So first of all, we have given let UR is equivalent to 1 over R into R plus 1 into R plus 3 into R plus 4. And VR is equivalent to 1 over R into R plus 1 into R plus 2. And what they are asking is show that VR minus VR plus 2 that is equivalent to 6UR. Okay. So if we know VR, we can write VR plus 2. Okay. How will write VR plus 2 is in the place of R. See, in the place of R there is R plus 2. So replacing this R by R plus 2. Then if I put R plus 2 here, R plus 3. If I put R plus 2 here, R plus 4. Okay. Then I can take the left hand side and I can show VR minus VR plus 2 is equal to 6UR. So what is my VR? 1 over R into R plus 1 into R plus 2. What is my VR plus 2? 1 over R plus 2 into R plus 3 into R plus 4. Okay. So I can take LCM. So R into R plus 1 into R plus 2 into R plus 3 into R plus 4. So multiply this by R plus 3 into R plus 4. No, we have R plus 1, R plus 2 here. Then R plus 3 into R plus 4. Here R plus 2, R plus 3, R plus 4 we have. Then R into R plus 1. Okay, so when you simplify this, R square get cancelled. So 3R plus 4R, 7R minus R, that is 6R plus 12 here over R into R plus 1 into R plus 2 into R plus 3 into R plus 4. Then if I take 6 out, I have R plus 2 over R into R plus 1 into R plus 2 into R plus 3 into R plus 4. Then this R plus 2 and this R plus 2 get cancelled. So what is this? 6 over R into R plus 1, R plus 3, R plus 4. That is UR. UR is equal to this way. Therefore, we have 6 UR. Okay. So this is easy. Okay. Just you have to show VR minus VR plus 2 is equal to 6. Okay. So next, what are they asking? Is can show that sigma R running from 1 to n UR. Sigma R running from 1 to n UR. So what is the meaning of this? Now they asked to show sigma R running from 1 to n UR, some term like this. Okay? 5 over 144 minus 2n plus 5 over 6 into n plus 1 into n plus 2 into n plus 3 into n plus 1. Normally we know sigma R running from 1 to n UR means U1 plus U2 plus U3 up to UN. Isn't it? So if I add all these terms from 1 to n, that I can write in this notation. Sigma means what? Summation. No? So what does this mean? You should know the meaning. Sigma R running from 1 to n UR means summation. This R is going to take values from 1 to n. 1, 2, 3, 4, 5, 6 up to n. So all this is this. But now you see they have used our hence. Hence means what? They didn't expect you to. Now you know you are. If you know you are, you can write U1, you can write U2. Okay? R is equal to 1, you can get U1. R is equal to 2, you can get U2. R is equal to 3, and you can add all these things. But they didn't expect this method. Hence, then why did they ask this one? VR minus VR plus 2 is equal to 6 UR. Then you should use this, isn't it? Yeah. So, sigma, okay. Sigma R running from 1 to n UR is U1 plus U2 plus U3 up to UN. Is U1, U2, U3? We can get using this term also. See, if you consider this expression, if I put R is equal to 1, I am getting U1. If I put R is equal to 2, I am getting U2. Then I can write U1, U2, U3 terms on this VR and VR minus VR plus 2. Then I know VR. Then using that somehow we can make this. Okay, hence, then without going using this normal method, it's pretty long also, isn't it? We can go to this one. Okay, let's see how to do it. Okay, the hence works, reduce works, you must be really careful. Okay, if they ask hence and reduce, if you don't follow the previous step, if you are doing in some other method, no marks. Right? The answer comes to no marks. Okay, so VR minus VR plus 2 is equal to 60. Okay, now I'm going to put R is equal to 1. Okay, I am writing this expression 6UR is equal to VR minus VR plus 2. Then R is equal to 1. But I will get 6U1 is equal to V1 minus V2. Then when R is equal to 2, 6U2 is equal to V2 minus V4. When R is equal to 3, 6U3 is equal to V3 minus V5. Okay, like this we can write up to 8. Okay, so when we get a term like this, you see this V3 and V3 are getting cancelled off. You can stop writing this and you can put dotted lines like this. Okay, then if you are writing 3 terms here, better write 3 terms from bottom. Okay, so R is equal to N, but R is equal to N, R is equal to N, and R is equal to N minus 1, N minus 2. Okay, R is equal to N minus 2, R is equal to N minus 1, and R is equal to N. Then 6U of N minus 2. That is V of N minus 2 minus V of N. See, R is equal to N minus 2. So 6U of N minus 1. Then V of N minus 1 minus V of N plus 1 here. Then 6UN. That is equal to V of N minus V of N plus 2. Okay? Now you are getting this. Can you, we had to find sigma R running from 1 to N U R. See? Sigma R running from 1 to N U R. When you add this one, U1, U2, U3, UN minus 2, N minus 1, UN. So that is what? Sigma R running from 1 to N U R. So we can add this. Okay? So when we add this, what we get? Okay, what we get is, see, 6 is here. Then in the bracket, you will have U1 plus U2 up to U of A. Okay, so that is what is U1 plus U2, U3, UN minus 2, N minus 1, U of N is UR. Sigma R running from 1 to N. 6 is there now. So I put a 6 here. That is equal to. Okay, so that is equal to here V3 get cancels. Similarly, V4, it diagonally it get cancels. Okay, and finally we have 4 terms. One is V1, V2, other one is these 2 terms. Okay, so here then we can write V1 plus V2 minus of V of N plus 1 minus of V of N plus 2. Okay, now we can find V1. How do you find V1? In the place of R, I am going to put 1. Then 1 over 1 into 1 plus 1 is 2. 1 plus 2 is 3. Okay, plus V2. 1 over here 2. 2 plus 1 is 3. And 2 plus 2 is 4. Okay, N plus 1 is in the place of R, I am going to put N plus 1. Okay, so N plus 1 here. Then if I put N plus 1 here, what I get? N plus 2 into N plus 3 minus 1 over N plus 2 here. Then N plus 2 into N plus 3 into N plus 4. Then what will we get? Then 1 over 6 plus 1 over 4 into 3 is 12. So 12 into 2 is 24 minus 1 over N plus 1 into N plus 2 into N plus 3 minus 1 over N plus 2 into N plus 3 into N plus 4. Okay, so when you simplify this, what we can do? We can take 24 as here. Okay, so 6 into 4 is 24, 4 here, 1 here. So 5 over 20. So we have to divide this by 6 also. So sigma R running from 1 to N U R 24 into 6. Everything will be divided by 6. 6 into N plus 1 into N plus 2 into N plus 3 minus 1 over 6 into N plus 2 into n plus 3 into n plus 4. Okay, so they have taken a common denominator. Okay, so how do you simplify this? So we have, so I will erase this. Okay, so when you simplify, what will you get is sigma r running from 1 to n ur. That is equivalent to 5 over 6 into 24. 142. 6 into 4 is 24. 2 balance 6 into 12, 2 is 12. Then 144 here. Minus you have to take LCM. Okay. So when you are taking LCM, what we have? Here n plus 1, n plus 2, n plus 3. Here n plus 2, n plus 3, n plus 4. Then we have n plus 1 into n plus 2 into n plus 3 into n plus 4. Okay, so here minus, here minus. So I'm taking the minus sign out. Careful now. Here n plus 1, n plus 2, n plus 3. So there should be n plus 4 here. Okay, there is a minus sign here. So I took the minus sign out. Okay, then I will get a plus sign here. So here we have n plus 2, n plus 3, n plus 4. Then here n plus 1. Okay, so my final expression is sigma r running from 1 to n ur is equal to 5 over 144 minus 2n plus 5 over 6 into n plus 1 into n plus 2 into n plus 3 into n plus 4. So that is the expression they asked me. Yes. Okay, so now you know how to think. Okay, so next part they are asking WR. Okay, so that is some new ideas. Okay, next what they are given is let WR is equal to, let WR is equal to U of 2R minus 1. U of 2R minus 1 plus U of 2R. Okay, deduce that. So using this you should deduce and show that sigma R running from 1 to n WR is equal to, show that this is equal to what? 5 over 144. 5 over 144 minus 4n plus 5. 4n plus 5 over 24 into n plus 1 into n plus 2. n plus 2 into 2n plus 1. 2n plus 1 into 2n plus 3. You should show this. So how can you show? Now let's say WR is this. So they are asking sigma, summation of WR. Then this expression we can take sigma both sides. Isn't it? Now they are asking summation of WR R running from 1 to n. So for WR we have only this data. So using this only we should find. So WR is this means if R is equal to 1, that W1 can be written in these terms, isn't it? So what I'm going to do is take sigma both sides. Sigma R running from 1 to n WR, that can be written as sigma R running from 1 to n U of 2R minus 1 plus U of 2R. Isn't it? Yes. So what is this? So just we can put and see. If I put R is equal to 1, what am I getting? 2 into 1 minus 1, U1 plus U2. If I put R is equal to 2, what I am getting? 2 into 2 is 4 minus 1, U3 plus U4. Okay? If I put R is equal to n, what I am getting? U of 2n minus 1 plus U of 2n. So what is this? The sigma R running from 1 to n WR can be written in terms of U. So what is this? This is the summation sigma R running from 1 to but 2n. Okay? UR. So here this R, it is starting from 1, it is ending at 2n. How did I find that? I could have started from 1 and n1 is this. So already we know something. What we know? Reduced part n. Already we have found in the previous part sigma R running from 1 to n UR. Then sigma R running from 1 to n UR we know. Then in the place of n, if I replace with 2n, I get the answer. isn't it? Yes. Sigma r running from 1 to n ur, that expression we know. What we know, sigma r running from 1 to n ur earlier, we derived it. What is that? 5 over 144 minus 2n plus 5. 2n plus 5 over 6 into n plus 1 into n plus 2 into n plus 3 into n plus 4. Okay. So in the place of n, I am going to put what? 2n here. Then what I get? Okay. 2 into 2n. 2 into 2n plus 5. Then 5 over 144. Okay. If I put 2 into 2n, what I get? 4n plus 5 over 6 into, here see, 2n plus 1. 2n plus 1. Then 2n plus 2. 2n plus 2. The place of n replacing by 2n. 2n plus 3. Then 2n plus 4. See? But what they have done is, now here 2 is common, and 2n plus 2 and 2n plus 1. So that 2 they are taking common in out here. Then 1, 2 is there, multiplying this by 2. Again 2 taking 2 common out. Then we will get n plus 2 here. Then multiplying by 2 here. Then finally we get 24 here. Like you can simplify. Okay? 4n plus 5 over 24 into n plus 1 into n plus 2 into n plus 1 into n plus 2 into 2n plus 1 into 2n plus 6. Show that the infinite series is convergent and find its sum. Okay. So let's see how to show the infinite series is convergent and find its sum. Okay. So what we are going to do is we are going to take limit on both sides. Limit, okay, sigma r running from 1 to n wr as n tends to infinity. Okay, infinite series they are mentioned. So if I take limit on both sides, limit as n tends to infinity, 5 over 144. Okay, minus 4n plus 5. 4n plus 5 over 24 into n plus 1 into n plus 2 into 2n plus 1 into 2n plus 3. Okay. Then this we can write as limit n tends to infinity 5 over 144. Okay. So I can take n now. Then I will get 4 plus 5 over n. Okay. So here also, if I take n now, what I will get? 1 plus 1 over n. Here also n now. Then n squared I will get. Let's see. 1 plus 2 over n. Similarly, we can take n now. Okay. Or else you can keep it as 2n plus 1 into 2n plus 3. Definitely this term is going to be 0. This n and this n get cancelled out. Definitely there will be n remaining. 1 over infinity is 1. 0. So this term is going to be 0. Or else what you can take n both sides down. Then n to the power 4 will come 1 over n cube also. That also will become 0. Then what is the answer? 5 over 144. See? Yes, it comes a finite value. Then what we can say? This implies, you're right. This implies that the series is convergent. Series is convergent. And its sum is 5 over 144. So that's all. Simple question. I hope you understood. So series question is normally easy. Okay. So series question normally come with permutation, combination. That's also an easy part. Okay. So I hope you understood.